frequently asked question, scale and performance in SaaS. I wanted to show you this, a bit of a story. So this is a very, very much simplified version of our compute and database infrastructure. So how SaaS is organized in the cloud. And what you may notice at the top of the screen, there are different types of workloads communicating with our infrastructure. So there are users working with Business Central clients, there are API calls hammering Business Central client or server at a very, very high speed. Especially LS retail workloads, they're really, really heavy on web service calls. So where are all these sessions going? So they go to a very, very smart load balancer. So they all hit a load balancer endpoint. And the reason why load balancer is smart, because it knows where to send these sessions for this customer. So the customer may have multiple users, 200, 300, 500 users, and this load balancer knows how loaded are our nodes, our compute nodes, and it knows where to send that particular user and where to create that particular session. All right, so far so good. All of our nodes are green, in this case blue, and there's plenty of capacity, but we're keeping our eye, our automated eye, on the CPU on these machines. So we need to make sure that it's not crossing 60% of CPU load. And at some point, one of these VMs hit above the 60% CPU. So what do? The smart load balancer stops sending new requests to that machine. So all of the requests are going to other machines, but this machine is just processing whatever is on this machine at this point of time. And some of you who are very curious, they might say, hey, but the users who are already on the machine, they might just go and use all of the capacity of the machine. And we say yes, but we kind of allocated 60% of, 40% of capacity for these users. So they will be fine, but at least no other users will be loaded and sessions will be loaded to that server. And then the situation evolves and, another machine gets loaded and another machine, and in the end, all clusters get loaded, and that's where we give up. No. Of course, we don't give up at this point of time. So actually, a little bit before that, so if I scroll that back, we already see that most of our clusters are getting really, really busy. So we start to provision another node. So another node which will be able to accept new sessions and new users and process the new workloads. And so on and so on and so on. And of course, when capacity goes back to normal, we scale down again, scale in again. So that's how the compute tier is working. So there's built-in flexibility in scaling. What about the database? We actually have a very similar story. On the database level, we monitor slightly different metrics. We monitor CPU, data I/O, log writes, and workers. So if they go beyond 80% of capacity, we do exactly the same. So we scale the database pretty much the same way it is scaled here in my PowerPoint. So we add more capacity to it. Another scalability vector which we have in the service is a thing called read-only replica. So it's a standard classic feature of Azure SQL, where each primary database can have a read scale out replica. So that database can only be used for read requests, and we do have that in our system. And you can instrument APIs and reports to talk to that read-only replica. So if you have a heavy web service workload, it's a great idea to instrument them to talk to that read-only replica, so that your main database, which is used by all other users, has enough throughput and capacity and a pleasant experience in general. So these are the scalability vectors inside of our clusters. So that was a quick introduction into our service intervals. Now, what you can learn from this quick presentation is that we do have auto-scaling capabilities in our compute tier, so we can scale out and in again. We do have auto-scaling capabilities in our data tier as well, and we, on top of that, do very, very active monitoring of overall capacity of our fleet. So with this auto-scaling plugged in, what are our numbers, you might ask? The numbers look pretty okay, I would say. So, for example, on the compute tier, we see that 99.68% of all of the sessions have enough capacity on the compute tier. So very, very, very few sessions end up being on the red machines, which are severely red. And if you could convert this into minutes, imagine an ordinary user working 4 hours a day with Business Central for a week. So for a period of 4 minutes, they may experience pretty bad performance because they would be left on that red node. But in general, outside of these 4 minutes, most of the workloads have enough capacity on compute. The same on database tiers. Our telemetry shows that most of our databases have enough database throughput, have enough CPU and disk IOs and all of these metrics. So we're doing pretty well there. So there's very, very few databases which fall into the slot where they are overloaded, and that affects the user workload. So the numbers look fairly well on the hardware side. And what I also wanted to show you then, what is the contributing factor to performance and scale? And that's where we see AL code is playing a big role in this story. And there are 3 basic things which we kind of typically see in affecting the performance. First of all is queries which lock each other. So if multiple different workloads access the same tables, trying to write into the same tables, they lock each other, and sometimes they deadlock each other, and then people have to wait. So that is a major contributing factor to performance. Sometimes there's just a long-running query. There's a missing index, there's a poorly designed query, and it just takes time to process. So even though our hardware is green, so we do have enough capacity, it is still running slow for these reasons. That is a really important realization. And another one is there's also a somewhat inefficiently designed code, which is sending too many queries to the database, and that can be also very slow, and it's especially bad in SAAS. If it is on-prem environment, that may not be noticeable that much, but if it is SaaS environment, so these multiple queries, it really is noticeable. So that's really important to realize. And so these are the 3 patterns that we see contributing a lot to performance. And by the way, it's not just partner code, it's our code, a lot of our code as well. So we are looking at all of these patterns, and we are trying to fix them all in our base application. But that's also a call to all partner applications built on top of Business Central to keep an eye on these patterns and then introduce changes accordingly. So another question which we often get is, what type of large customers do we have in our service today? And these are some of the metrics that we assembled for you just as an example. And I need to do the disclaimer that these are not the best and the worst or the highest numbers that we have. These are just samples. And they are per one environment, so there's one particular environment. They are not maximums of what we can operate, they're just examples. And the data size, for example, there's a 500 gigabyte database in our service. It's running seemingly fine, it has enough capacity and throughput, so there is an example of that customer. There's a number of records and various tables which can help you assess the number of users, for example. You see in a user table there's 1,000 records, presuming that there's 1,000 users working with that system. There's GL entry table with 70 million records in it, and item ledger entry with 7 million records in it. In retail business it can get very, very high, but again, this is just an example. Transactions. So these are some of the examples of the transactions we see going through our stack. So fairly advanced workloads, 6,000 sales orders posted in a day. And one particular case, we saw somebody posting a sales order with 11,000 lines. That took roughly 20 minutes, which translates into 7 lines per second. So that was an interesting invoice to receive, our sales order. And finally, one of the most important topics is web service calls. So you can see the numbers are fairly substantial. In one day, the number of calls that we make in 6 million calls. And particularly interesting one, that in 1 minute we see customers hitting 8,400 calls per minute. And here I need to make a disclaimer that our official limit, which is described in the documentation, is 600 calls per minute. And yet, people are doing 8,000 calls per minute. So the reason why we decided to put 600 number in the official documentation is that we would like to keep everyone fit. So yes, the system can handle a lot of throughput, but it's not the place to get comfortable. It's the goal is for you to get to the point where you refine your web service calls, where you refine your AL statements to actually hit this limit. So yes, the system can handle, but you need to strive towards fewer calls. So that is the message of that. And we documented a lot of performance improvement hints and tips in this friendly URL, AKMSBC performance. So that's the only thing you need to remember. There are some guidelines for how you configure MSP, how you design your AL code for better performance, how you use Business Central to extract data from it. Many, many different interesting topics. And we keep refining this repository. But looking at this slide, and it's a good one to take a picture of, looking at this slide, you can see how much we invest in performance overall. I mean, when you zoom in later on after the presentation into each of these bullets, you can see that we literally not leaving any stone unturned when looking for performance improvements. So working with the client rendering performance, application processes which are slow, redefining data types, employing read-only replica. There's many, many, many different types of performance improvements which are going into our MST, into application, client, and service. So there's many, many performance improvements. And version 20 is not an exception. Most of our investments go into performance, scalability, and security. So these are top 3, I would say, investment areas in Business Central team. So performance is a huge focus of our teams. All right, so managing changes.